All right, when you come out here to run this thing, a couple of things you got to do right away, and these are all these sheets I've got hanging up here. Number one, turn on the computer, make sure that thing's on. Your login and password are there, all you need to know is the password. All right, it's encrypted, but it is what it is. Make sure that the air pressure is on. We got an air line coming down by the mills over there. The valve's got to get turned on so you got air pressure. Table's got to be on. Plasma cutter down there has got to be on. All right, 4 things got to get turned on so you're ready to go. When you come over to the computer, scoot this over. Looks just like the computer screen we covered in the class. You got your little icon right down here for Plasma Camp. I'll open that thing up. The first thing you need to do is connect the computer to the table so they can speak to each other and operate each other. So I'm going to go machine, initialize. When I initialize it, it'll find its home. Who's done graphs in math class before, right? You know what 0, 0 is on a graph? That's 0, 0 of the machine right there. And then X goes this way, Y goes this way, our Z gets moved up and down right here on our keypad. I can move my torch around now on my keypad right here. So I can move like diagonally if I want. I can move straight down my sheet, go over on my sheet. I can bring it down on my Z on the sheet, just like this. The torch needs to stay exactly 0.06 inches off the steel at all times we're cutting. Is that feasible for you to do? No. The machine is supposed to have what's called ohmic sensing. Ohmic sensing means the torch can sense the material and it'll stay at 0.06 inches off no matter how warped or twisted it is. It'll move up and down. On this old beast, it doesn't work anymore. So we have to drive the machine. As you're cutting your piece out, you're going to be sitting in your stool watching the torch and watching the arc and moving the torch up and down as it cuts it out. If you get too close to the metal, molten metal will actually spatter up inside the tip and wreck the tips, and it's going to move the sheet. If you get too far away, the arc gets too long, and it gets hotter, it's more intense, and it'll burn out the tips as well. And a set of tips for this is $40. So one mistake can get a little expensive. Does it happen? Yes. Am I going to get mad if it happens? No. I get it. We're here to learn. But really pay attention to this when you're running it. If you want to cut something out, you cut out the Minnesota Wild glass block. I'll just go in here and open something up. We'll file open. Let's see here. Does it do maybe, what's that?
Stomach rack.
No. Not enough room. I'll do a stay at home sign. So I open up the stay at home file, and there'll be a folder on this computer full of files you can choose from, whatever you want to cut out. My yellow crosshair is where my torch is, out on the table, right? So I'm going to drive this over to my 0, 0 point I want, the upper left-hand corner. Let's make sure we miss that. I think I'm gonna. There we go. That'd be my 0, 0 point now for my part. Now I can come on here and grab a Minnesota home. I'll highlight it. I'll hit M for move. I'll drag it down there. Just like that. I'm going to zoom in on it. Okay? Now I've got other things cut out of the sheet. Is my Minnesota home going to fit? This is where you use your Alt-V, Move To button. I'm going to hit Alt-V on here, and I can drive it over to the edge to see if it'll stay on the sheet. Not even close. See that? It's not going to fit on there. So I can make it smaller. I don't know if the letters will turn out, but I'll make it smaller just for this. And then Alt-V again. Yep, it fits. Hit Alt-V again, I'll run it down to the bottom. Yep, it fits. I'm kind of running the outline of the shape to make sure I'm not going to hit anything. Ah, I ran over that, didn't I? See that? Move over a little bit. Now we're good. Okay? Is that clear so far? Make sense?
Yeah.
Now I'm ready to cut. All I have to do at this point now is check my torch, make sure I'm roughly 0.06 inches off, which isn't much, right? 0.0625 is 1/16 of an inch. So you're thinking about a 1/16 of an inch, how far off you need to be the sheet the whole time. And so now my part is highlighted, like that. All you do is hit machine cut, and it's going to go. The only thing you got to watch for is it's cutting out are called tip-ups. If I'm cutting something out, like on Minnesota Wild, this thing right here was cut out in the middle of the head, right? This thing fell down and tipped up like that on the sheet. If that happens, you got to hit stop right away on here, which is basically pause. You got to pull that thing out. If the torch or the carriage hook only hits that, your whole sheet's going to move and mess up your whole entire part. And then you're starting over. So pause it, pull your part, that tip up out of there, hit start again, you'll be good to go. These little things we drop in our bucket down here. Questions? When you're cutting them out, these goggles are just fine. These are a shade 6. Shade 6 is all you need for cutting with a torch. It's not as intense of an arc as a welder is. So your welding hoods, you put them on a grind mode, which is like shade 6, you'll be just fine. You'll protect your eyes just fine. So let's cut this out together. You can keep an eye on kind of what I'm doing here. All right, put your welding hoods on, and we'll go. That's all the auto darkening helmets we have. Where are all the rest of the helmets? Okay. All right, we're ready? Huh?
There's one over there.
Megan, I want you to run down and grab that one down there so you can see what's going on. These other helmets, you're not going to be able to see much of what's going on. You guys aren't going to watch? That's fine. Yeah, you head back to the room if you want. You guys just ran the last try, so that's fine. All right, come on in close. You need a helmet or rope? Alright, here we go. Come on in close so you can see it. And again, the whole time this is running, I've got my fingers on the Z up and down buttons. All done? Check it out. Now you notice when you look at it, come here look at it, the E got melted away. I scaled this thing way down and made it way smaller, so the letters didn't turn out like I thought they would. The water collects all the dirt and dust that come off here when we cut these things out. Before I got here, they didn't have a water table. If you look like that pipe that runs along the back of the shop here, see how black it is on top? That's dust from this machine. See that pipe back there? How black it is? The whole shop was covered in the dust. So this makes it a much cleaner environment for us to work in. Plus, I don't want you guys breathing all that dirty dust in. All right? And it helps your metal from warping. It keeps it cool. If that wasn't on there, the sheet would be all warped and twisted up. So now let's cut out. Let's pop it out of there. You get what's called dross or slag on the back from the cut. We take a grinder with a wire wheel and go over that, and it pops off of there. And then you can clean it up and paint it. This particular one, we're going to bend on the brake. I'll show you that real quick. That was pretty good to see that. The brake, I'll bring it over here. This edge right here on the brake where you line up the bend. I don't want to line this one up. I'll line it up like so. Clamp it down. We've got a digital gauge here. I'll turn it on. I'll zero it. I'll bend it to like 100 degrees. So watch that gauge change as I bend it. 96. 7, 8, that's good work. There we go. You guys can do this on all sides. Just like that. And like I said, look at these racks we made for our toolboxes on the lathes. We made those with the plasma cutter. Right? When you start cutting those complex shapes and bending them up, it makes some really cool things with this machine. Questions?